This lesson is on adding and subtracting radical expressions, and in the warm-up I introduced like terms based off their previous knowledge of like terms for polynomials to introduce like radicals. That's very similar, just that you have to have the same number underneath the radical to be like radicals. And so I talk about, before I hand them an independent practice, the worksheet, I want them to think about which numbers can combine, which ones look like they can combine because of the factors that I know create that number, that multiply to make that number. Square root of 32 and square root of 8. Well, I know that 4 is a factor of both of those, 2 is a factor of both of those, so those could possibly be like radicals. Sometimes they're not, but go ahead and start simplifying that. And then if you break that down, you can break that down to 8 times 4. Well, and then that end down to 2 times 4 and 2 times 2. And if you want to go on to prime factorization, that's 5 2's basically that have broken down and being multiplied to create 32. So 2 pairs of 2's, so 2 times 2 comes outside, and a 2 is left underneath, so that's 4 square root of 2. You also have 4 times 2 makes 8, and perfect square of 4 you could have pulled out right there instead of doing prime factorization. That's going to be plus 2 comes out for the 4, and a 2 is left underneath. So those did create like radicals, so now you can combine the coefficients in front of that. 4 plus 2 is 6 square root of 2. The next one, 7, is a factor of 28, and it's also a prime number, so it probably will not come outside the radical. And so you're going to have 4 times 7 makes 28, and so that's going to be 2 times 2, and a 2 comes out, and a square root of 7 is left underneath, plus 3 square root of 7's. Well, just like if you had a 2x plus a 3x, that would be 5x. So if you have 2 square root of 7's plus 3 square root of 7's, that's 5 square root of 7. And that's completely simplified. Again, 3 is a factor of 18, so it might end up being like radicals. So actually, the largest perfect square in that is 9 times 2. Square root of 9 is 3. And then 2 is left underneath, minus 2 square root of 3, and that actually does not work out because 2 ends up underneath the radical. Those are not like terms, so you have to leave that expression exactly the way it is. It doesn't combine any further. That's completely simplified. Another thing you might see is that if you had square root of 50 plus the square root of 25, well, 25 is a perfect square, so those aren't going to end up being like terms because 50 is not a perfect square. Now, 25 is a factor of both of those, but the perfect square simplifies, and then square root of 25 times 2 times square root of 2 underneath there, the 25 would be a 5 comes out, and then the 2 is left underneath, so the final complete simplified expression is 5 square root of 2 plus 5. You cannot combine those because they don't have like radicals.